Good evening, guys. I'm gonna cover section 4.1 of exponential functions. Like I told you in class, let's try to go over. On the test, there's not gonna be these word problems of exponential decay or like compound interest rates. So don't focus on that. Whatever I cover here, just go over that. The objectives are here: define an exponential function, graph exponential functions, develop formulas for simple and compound interest rates. So we're not gonna do that. Understand the number e. I'm gonna do it a little bit. Graph the exponential functions. We're gonna do that. We're not gonna doing this thing. We're gonna graph this and we're gonna define this. So here, exponential function, a function f of the form f of x a to the x equals, I'm sorry, f of x equals a to the x has to be greater than 0, and it cannot be equal to 1. It cannot be equal to 1 because if a equals 1, whatever you put for x, let's say, right, whatever value you put for x, you're going to get always constant, right? You're going to get the same number basically. So if I put x equals 1, I'm going to get 1. If I put 2 for x, I'm going to get still 1, right? Because any number, 1 to the power of any number is always going to be 1. And it has to be, it cannot be 0. That's the reason they say it has to be greater than 0, because if you put 0 here, any number to the 0 power, it's going to be 0 or undefined situation, right? If it's a to the 0 to the 1 is 0, 0 to the 2 is 0, and so on and so on. And if you put 0 as for x, right, that's going to be undefined, right? So be careful with that, right? F of x is called an exponential function with base a and exponent x. Its domain is all real numbers, basically, right? Okay, so here, oh, I did this problem, sorry. Okay, give me 1 second. Here, they're asking you to evaluate. Basically, you just need to plug this here, this value in the function, right? So you will just do f of 4, basically. So this is going to be 3 to the 4 minus 2, which is going to be 3 to the 2, which is going to be 9, right? You can do that, I guess. Then negative 2, you plug that here. So it's going to be g of negative 2. So that's going to be negative 2 times 10 to the negative 2. You know that this is going to be negative 2. You're going to have a negative exponent. So that's going to be 1 over 10 to the second power, right? And then this is equal to negative 2 over 100. You simplify that, you get negative 1 over 50. That you should get that, right? Then the next one, you need to plug negative 3 halves here in the function. So you get h of negative 3 halves, right? So that's going to be 1 over 9 negative 3 halves, right? So you can put the negative 1 inside here, right? And then you can multiply that by 3 halves. So negative 1 over 9, it's reciprocal, right? It will be just 9. And then you can do this thing, right? So that's 9. You can do either you take the square root first and then you cube it. So that's going to be 3, and that's going to be 3 cubed. It's going to be 27, right? You should be able to know how to do that. If you don't remember that, what I did here is 1 to the negative 1, right? 9 to the negative 1. Remember, we don't want negative exponents. So this in the denominator goes in the numerator as positive. This in the numerator goes in the denominator as positive. So 9 over 1 is 9. That's the reason I said that's 9, right? This guy right here, right? So you can just think about that. Okay, so you can see how they did it, right? And the last one is just plugging 3.2. At that point, you can use your calculator, right? For that 3.2. Okay. So rules of exponents. So this is the power rule, right? Ax times ay equals ax plus y. E to the 0 is always 1. We talk about that many times. You have here the power rule. So ax to the y, right? It's going to be axy. And if you have that this situation right here, then that's going to be just basically you distribute that exponent to then the constants or that are inside the parentheses, right? This is quotient rule, right? This is reciprocal, right? And here you can do the same, right? A to the x and b to the x again, right? So you can kind of distribute it. Let's do this together. Okay, so here. So you have the same base. This way. you have the same base, so you have to add the powers, right? So this is going to be 6 square root of 27 plus square root of 12. So you can simplify those radicals, right? So this is going to be 27. You need to simplify. You have to do the prime factorization, right? Which is, I mean, you can do that forever, but I'm just going to do it fast this time. So this is going to be 9 times 3. So square root of 9 is 3. 3 doesn't have a square root, so it stays inside. And yeah, that's that, right? So this 27 simplifies to 3 root 3. And then the 12 simplifies to 4 times 3, right? And that's going to be 2 root 3, right? So this is going to be plus 2 root 3. Since they have the same right, you can just combine them, right? So this is 5 root 3, right? So this is going to be 5 root 3. At the point, basically, you're done, right? Or you can just do what these people did, 6 to the 5th, and then they power it to the cube root. So that's 7, 7, 7, 6 to the third power. Yeah, that's all you can, I mean, that's what you can do at that point. Okay, so here, 6 to the square root of 3 to the square root of 3. So you just multiply these two together, right? And I mentioned to you many times, if you have root 2 times root 2, that's just a number. Root 3 times root 3, that's just a number. Root 4, as long as they're real, right? That's just a number. 5 times root 5, that's just the number, right? So that's going to be what? Just 6 times 3, right? And that's going to be 216. Okay? So here you have what? They want you to graph it, right? Don't think too much about this thing, okay? They give you a lot of values. I know it's a lot of things to learn, but the main thing, to make it simple, you just here, exponential functions, they have horizontal asymptotes. So the horizontal asymptote is something like this, right? Like this, right? Something like that. So since there's no number here next to that, that's assumed to be plus 0. So in this case, the horizontal asymptote implies that y equals 0, right? And then if you want to graph it quickly, right? If you don't have too much time because you're taking a test or whatever, depending on how detailed they want the answer, right? But anyway, if you want to do this quickly, you just say put numbers that they're easy to plug. So for example, you have a function 3 to the x. So pick 0, right? Because you know that any number to the 0 is always 1. So 0, I mean 3 to the 0 is just 1. And then put 1, right? So that's 1. That's going to be 3, right? So 0, 3, 0, 3, 0, 1, and 1, 3, right? So 1, 2, 3. So that's about here. And that's about here. That's going to be the y-intercept anyway, all right? And the asymptote was at y equals 0, right? So you just do the asymptote here, and you can see the pattern, right? If you want to plug one more point, you can say maybe like a -1, right? So that's going to be just 1/3, right? Because if you put here 3 to the -1, that's going to be 1 over 3 to the first, which is 1/3, right? So you know 1/3 is about 0.33 about here, right? So then you graph this thing. So now the question is, what's the domain? The domain for exponential functions is all real numbers, so negative infinity, infinity, right? And what's the range here? Well, the range is the y values, right? So the y values comes from what? From the horizontal asymptotes, and that's not included. So that's going to be 0 to infinity. That's it. You're done. That's all you have to do. So for the next one, the next one is asking you to grab this thing, right? So again, pick easy values. I'm gonna pick 0 because any number to the 0 is always 1. And I'm gonna pick maybe 1 because it's gonna give me 0.5, right? And then I can pick -1. So -1 is just gonna give me 2, right? So if I have to grab this really fast, remember there's no number here, so it's plus 0. So the horizontal asymptote is y equals 0, right? So yeah, so this is 0, 1. So let me put the asymptote first. And then this is gonna be 0, 1, that's going to be here. And then 1, 0, 1, 0, 0.5, so that's about here somewhere. And negative 1, 2, right? So that's going to be around here somewhere. So you just graph it, right? Right? So the domain, again, is all real numbers, negative infinity, infinity. And the range is from 0 to infinity. And that includes 0 because 0 is the asymptote, right? That's it. You're done. And then that's how they explain here, right? You don't need to do all that stuff. So here they have properties of exponential function. If you read this, that's a lot, right? If they're asking you this, you can explain that on the test. So I'm gonna leave that to you to read it. I'm just gonna solve the problems to show you how it's done, right? Okay, so read these things. So here they're asking you what? To graph it, right? So the questions, they're most likely gonna be like this. So they want you to graph, right? So here in this case, it's a little different. So for A, you have what? 2 to the x plus 2, right? So the horizontal asymptote this time is this guy. Horizontal asymptote is y equals 2, right? So this is going to be 2 here, right? So your range is going to change. Just keep that in mind. I'm going to put, it's a dotted line, but I'm going to put, make sure when you're taking the test, you bring a ruler, okay? I'm going to, oh my God. I'm going to bring I'm just going to put a line to make it faster, okay? But it's a dotted line anyway. Okay, so we have a horizontal asymptote. And now we need to find the numbers, right? We need to do the graph. So this is x and y. And this point, you can put easy values, put 0, that's always 1, right? So that's 3. And then put 1, that's going to be 4. And then you can put negative 1, right? If you want, right? So that's negative 1 is going to be 2 to the negative 1, that's 1/2. So that's going to be 2.5. So 0, 3. 0, 3, it's about here, right? So 0, 3, 1, 4. That's here. And then you have negative 1, 2.5, right? So that's about here. So you can see the behavior of this function, right? If you want to plug more values, you're more than welcome to plug more. So now what you need to do is the domain. What's the domain? All real numbers, no problem. What's the range? Well, the range is from the asymptote and up, right? Because this is a vertical shift, right? So this is going to be negative 2 not included, infinity. That's it. You're done. You're done. Okay. That's that one. That was 2, right? I mean A. So now you can do B. So this is going to be this is a vertical shift, right? Because you went up. And this is going to be a horizontal shift, right? Horizontal shift. Okay. So same thing, right? Just need to plug that in the function and do the same thing. So B, I'm gonna use well, there's no number here, right? So that means the horizontal asymptote is y equals 0, right? So you do this thing again, the graph, and then you do the horizontal asymptote first, okay? And then you just plug numbers, right? X, y. So this is going to be 1, 2, 1. 1 minus 1 is 0. Any number to the 0 is always 1. You can put 2. That's going to be 2, right? 2 minus 1 is 1. 2 to the 1 is 2. What else? Now you can put negative 1. You can put if you want. Negative 1, that's going to be negative 2. That's going to be 1/4 or 0.25, right? So now you can graph this thing. So 1, 1, 1, 1. Remember, it's a shift to the right, this thing, right? Because x minus 1 equals 0. You add 1, is a shift to the right, right? So it went to the right, 1 unit. And now you have 2, 2. And then you have negative 1, 0.25. So about here somewhere. So you can see the behavior of this function, right? When you have the function, growing from left to right, this is exponential growth, right? This is exponential growth, okay? And this is all, the first one is, it was also exponential growth. So what's the domain? The domain is all real numbers. And the range is all, I mean, in this case will be from the asymptote, so from 0 to infinity. Done. That's it. Okay? So you should understand this thing at this point. I'm going to erase these ones because I need the space to do C and D. Okay? So C, I'm going to put that in another color. C, again, right? So the first thing you should do is, there's no number here, right? This is plus 0. So the horizontal asymptote is y equals 0 for C. And now you need to plug numbers, right? So what you can do is just do the graph first, right? And okay, and then now you need to plug the numbers x, y, right? You know what it is. So just so put 0, right? Any number to the 0 is always 1, but be careful, right? Because any number to the 0 is 1, but you have a negative here. So watch out for that. So that's going to be -1. Be careful, okay? Then you have to put 1. So that's going to be -2. If you put -1, that's going to be negative, that's going to be 1/2. That's going to be -1/2, right? Yeah. Okay, because 2 to the -1, that's a -1/2, right? So this is 0, -1. That's right here. And we have 182, right? 182, that's right here. And what else? What? And -1, -1/2 both here, right? So you can see the pattern. Remember, you cannot touch the horizontal asymptote, right? At y equals 0. So this is a reflection over the x-axis, right? Is a reflection over the x-axis. Okay, and next number, B. Oh, what's the domain here? I forgot. The domain is negative infinity, infinity. And the range will be from where? From negative infinity, in this case, right? Because it comes from the bottom to the top, so to 0. Okay, I mean, this is the range of the domain. Okay, now D. D, be careful a little bit, okay? So again, this is plus 0, horizontal asymptote equals y equals 0, right? And now you graph, right? And you pick points again. Pick easy points, right? Don't pick hard points. So x, y, so pick 0. Any number to the 0 is always 1, right? Now you can put -1. -1 and negative, it's +1, so that's going to be just 2. And what else I can put? 1, right? So that's going to be 1/2. So now you can graph it, right? The horizontal asymptote is at 0. Okay. Now I need to graph it. Let's see, 0, 1. That's here, right? And then they asking me from -1 and 2. That's right here, right? And then 1 and 1/2. So 1 and 1/2 above here. So remember, you're not touching the horizontal asymptote. So this is exponential decay, right? Okay. So what's the domain? Negative infinity, infinity. What's the range? The range will be from 0 to infinity, not including 0 because 0 is the asymptote. Okay, that's how you do that. So you can take a look about what they did here, the reflection and all that, right? I'm just telling you how to solve the problems fast. Okay, here, this thing. Okay. So they give you the model here, right? So they say find the exponential function. Find the exponential function of the form, this form, right? So that remember that this is the model, this thing right here. Okay, this is the model. So recall that this is x and y. And remember, y equals to f of x. Therefore, I can say that this is 18 equals c, in this case, to the a to the -1. So now if I multiply by its inverse, a, here, this cancels out. So I got c equals 18a, okay? Now I have to solve for the other one, right? For the other order pair. So this is x and y. So same thing, right? Y equals 2 over 27. And this is going to be c times 4, right? What is that? C a to the 4, right? Okay, but I already have c from here. I have c from here. So the only thing I need to do is just plug it in, right? So this is 2 over 27. C is 18a times a to the 4, right? So it's gonna imply that this is gonna be 18a to the 5, 2 over 27. So I need to solve for either a or c, doesn't matter, right? Yeah, so I'm gonna multiply by its reciprocal, right? And this is gonna cancel out, and this is a to the 5 equals, well, this simplifies to 19, right? 19 times, and here I have 1 over 27, right? Now to make it simple, just recall that 19 is the same as 3 squared times 27 is the same as 3 to the 3. So that means that I can, put it together, right? Using the product rule. So this is going to be 1 over 3 to the 5, and this is going to be 8 to the 5. So if I take the fifth root in both sides, right? If I take the fifth root in both sides, right? This cancels out, and I get a equals the fifth root of 1, the fifth root of 3 to the 5. So the fifth root of 1 is just 1, right? 1 times 1 times 1 times 1 times 1 is just the fifth root of 5. I'm sorry, the fifth root of 1. And then here, the fifth root of 3, you can just do this. So you get 1/3. So you got a already. Now you can solve for c. This is 18 from here, right? 18 times 1/3, so that's going to be 6. That's it. That's how you do that one. So these are the two solutions. Okay, we're not doing this. I already told you in the beginning of the video that we're not doing this. So you can skip all that stuff. Okay, and this is the last part of the video, right? So they say the value of e. So they say as h gets larger and larger, 1 plus 1 over h to the h power gets closer and closer for a fixed number or to a fixed number. This irrational number is denoted by e, which is a rational number, right? And it's sometimes called Euler's number, right? The value of e to 15 places is this thing. Now the question is, how did they get this thing, right? To get this value, I mean, you have to know calculus, and some of you were telling me that you know how to do it, right? You took calculus in high school. So let me explain to you how you can get this thing, okay? Okay. So they're saying that this value gets larger and larger. So you know that this is a function, so a model or whatever, right? So this is 1 plus 1 over h, the h power, right? So that's the model. If I take the natural logarithm in both sides, I got ln y equals, before I take the natural logarithm, they said that h gets larger and larger, so I have to take the limit. The limit as h approaches 0, I'm sorry, h approaches infinity because it gets larger and larger. 1 plus 1 over h to the h power, right? Now, if I take the natural logarithm, I get this, right? And because now I have ln 1 plus 1 over h to the h. Just recall that when you have the natural logarithm, you can move this exponent to the front, right? Using the power rule. So this is ln(y) equals the limit as h approaches infinity, h times ln 1 plus 1 over h. You can rewrite this now as the ln(y) equals the limit as h approaches infinity of ln 1 plus 1 over h to the 1 over h, right? This is the same equivalent to this previous one. Okay. Now, what I need to do is, if you plug infinity right now in the function that you have here, or if you apply the limit, that's gonna give you well, it's gonna give you a ln of 1, which is 0, and here you're gonna have 0. So you're gonna have this in indeterminate form, right? You're gonna have this indeterminate form, right? So if you have an indeterminate form, you cannot do that. You cannot plug and just get the limit, right? So what you can do, you can use L'Hopital's rule, right? If you took calculus, you know that L'Hopital's rule, right? L'Hopital's rule, and you have to take the derivative with respect to h, right? Yeah, like here, right? So ln(y) equals the limit as h approaches infinity of the derivative of this function, right? So the derivative of ln, you can think about this thing as u, okay? So this is u, okay? So let u equals 1 plus 1 over h, right? So the derivative of ln u is 1 over u prime, right? So this is equal to what? 1 over 1 plus 1 over h, and the derivative of u is u prime, right? So u prime means the derivative of a constant is 0, and you need to take the derivative of this guy. So that would be h to the -1, right? So that means that this is going to be negative h to the -2, right? Which implies that this is going to be -1 over h squared. So you need to multiply this as -1 over h squared, right? So now your numerator becomes -1 over h squared over 1 plus 1 over h. And then you have on the denominator, you need to take the derivative, but we already take the derivative of that. So that's just -1 over h squared again, right? So if you do that, right? First of all, these signs, that's it, they disappear, right? Because negative is a positive. Now you need to multiply top and bottom by h squared. So this cancels. So you got 1 over 1 plus 1 over h over 1. This dividing by 1 is the same as the fraction, right? So now you can apply the limit. So the limit as h approaches infinity of 1 over 1 plus 1 over h. Now if you plug the infinity here in this value here, right? And that what's going to happen is that you're going to have ln(y) equals the limit as h approaches infinity of 1 over, well, this is going to be 0, right? Because if it approaches infinity, 1 over a bigger number, it's going to approach 0. So this is going to be 1 over 1, basically, which is going to be 1, right? So the limit disappears, so you're going to get just 1. Now you have a logarithm equation, so you can make this into a exponential function. Remember, the base of ln is e, right? So you can say e to the first equals y, right? So y equals e. Now, if you go back to the problem that we start by, we claim that y was equal to 1 plus this. So this is equivalent to e because y equals to e. Therefore, y equals e, right? So that's why that thing, it gets larger, it is approaching e. And we said that it was 2.718281828 and blah, 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 right? So if you're asking me, do I need to know this on the test? No, you don't. But I want to explain to you where it comes from, right? Because some of you may be curious about that thing. So it's a little long process, right? But you can try it, right? If you know calculus, you should you should know what I'm talking about, L'Hopital's rule and derivatives and this kind of stuff. Okay, so this is the end of this video. Thank you, and I'll see you in class. Have a nice day.